Good morning, sir. Today my topic is capacitance. A capacitor is consists of two conducting plates and plates A and B is separated by free phases of dielectric medium of thickness D. Thickness is D. A with permeability E. The conducting plates carry equal to the opposite charges. Yes. Due to the force of attraction between the charges, electric field, a normally conducting surface established the flux flows from the positive charges and negative charges. And potential difference V is developed across the plates. The potential difference across the plates is proportional to the charges on the plates. Q is equal to CV. The proportional constant is called capacitance and is defined as ratio of the charge Q is the conductor to the potential difference V between the conductance is denoted by CV is equal to Q by B is Faraday or coulombs per watts. Capacitor consists of two conducting plates A and B. A and B. A is positive charges, B is negative charges, is voltages, is flux, proper permeability is E. Above the shown figure, a parallel plate capacitor A and B, two plates conducting two plates separated by free space by electric medium thickness D. The flux with the permeability. The conducting plates carry two opposite charges due to the normal phase attraction between the charges and electric field. The separation between the plates is measured on the area of the conductance is S. Then the capacitance of the parallel plate capacitor C is equal to Q by V. Charges V is charges, V is voltages, V is equal to epsilon naught S by D. D is meters and S is conductance. S is equal to Q by V is equal to permeability D by V S by D. Led to the parallel plate capacitor, the X and Y plane to be separated by a distance D. D is meters around the Z axis. Let epsilon naught is the permeability by electric medium between the plates and S. The surface of area of the conductance is the plates carrier and opposite charges. The electric field is developed between the plates, which can be obtained from the electric flux density. D bar is equal to rho S Az equal to Q by S Z bar, and E bar is equal to D bar by epsilon naught permeability Q by permeability S Az. The potential difference V is equal to integration E bar into Di bar equal to Qd by epsilon naught permeability S volts. The capacitance is equal to Q by V. The permeability S by V farads. The capacitance depends on the physical properties of the capacitors. The capacitor with the different dielectric materials. Consider two parallel plates conducted is separated by different material. As shown in the figure, at B epsilon naught 1, epsilon naught 2, permeability 1, permeability 2, and so on up to permeability 2 be the permeability of the dielectric materials, and meters, D1 and D2 up to Dn. The thickness of the same area. The this side is positive, negative charges is are separated. F01, F02 up to N. The parallel plate capacitor with difference, the potential difference across the plate. So is equal to integration I E bar into D I bar is equal to E1 D1 up to En Dn. E is equal to D by epsilon naught by Q naught is equal to S into epsilon naught. The capacitance is formula is C is equal to U by V. S by D1 by D2 is farads. The capacitor connected in series. In the previous discussed the capacitor connected in parallel. This is discussed capacitor connected in series. Capacitor of different dimensions are connected in series. Series. C1 epsilon naught 1 by S1 divided by D1. The epsilon is permeability is meters and areas. Up to Cn epsilon naught n Sn d by divided by dn. Up to C1 C2 up to so on Cn. The capacitor connected in series, the potential difference is the capacitor connected in parallel. The capacitor are connected in parallel is showing figure the potential difference capacitor with the total charges on the capacitor. A charges Q1 plus Q2 plus up to so on Qn. Here QC are separated voltages. The capacitor connected in parallel. The total capacitance is equal to the sum of the individual capacitance. The energy stored in a capacitor, W is equal to 1 by 2 CV square. W is energy in joules. Applications of capacitor is supply filtering, a single coupling and decoupling, timing circuits, motor starting, energy stored is so on. Advantages: capacitance or advantages, simple construction, heavy efficiency, fast charging and discharging, and capacitance is more important. Capacitance is more electrical properties. Capacitance play a role of electronic and electrical systems. Dielectric materials. The electric insulating materials is placed between capacitor plates to increase capacitance by reducing the electric field. Example: air, mica, glasses, paper, plastic. Dielectric materials. Dielectric constant relative permeability. Capacitance with dielectric, capacitance without dielectric. Higher dielectric constants, higher capacitance. A leakage current, a small current flow the even capacitor is charged due to imperfect insulation in the electrolytic capacitance is a high leakage than thermic charging is capacitor RC circuits when connected to DC sources. V of t is equal to Vs of 1 minus e power minus t by RC. Voltage rising exponentially, a time constant tau is equal to RC. The discharging of capacitor V of t is equal to V naught e power minus t by RC. The voltage decreasing exponentially after 5t. Capacitor is mostly discharged. Advantage of using a capacitor: store electrical energy, blocks DC, AC improve power factor, smooth ripple voltage. Disadvantage limited energy storage, voltage rating restriction, electrolytic capacitors have limited life. A practical example, AC is equal to 10 microfarads, voltage 12 volts is W is equal to 0.0072 joules. The capacitor is the ability to store charges that depends on geometry and electric. The capacitor is essential in electronics. Factors affecting capacitance: area of plates, large areas, more capacitance; distance between plates, a smaller distance, a more capacitance; dielectric material, higher dielectric material, constant, more capacitance. Energy stored in capacitance, W is equal to 1/2 AC V square. Capacitance is the ability of device to store electric charges. AC is equal to Q by V. The two conductors are separated by insulator and connected to a voltage sources. Charges do not jump across the dielectric. Instead, electric field from between plates. Energy is stored inside the electric field. C is equal to Q by V. Microscopic free electrons move on to another place. The electric are pulled by heavy other plates. Dielectric molecules are rearrange polarization. Opposing charging is phase on each other is electric field builds up. The wire is stored between not inside metal. Capacitance arises due to the electric field storage, depends on the geometric and dielectric energy stored in field, not matter. Time behavior of exponential frequency behavior makes a capacitance in AC circuit.